Hello friends, welcome once again to mathematics video lecture series. We are studying complex numbers, and today I'll be talking about a very important topic in complex number, and that is the exponential form of complex number. And it's a very useful form. We'll see how. Okay, so let's begin without wasting any time. Exponential form of complex number. Okay. Now you don't really have to go into the derivation part or how we arrive at this result. This is a result that you need to remember and use. Okay, the result is that cos theta plus I sin theta can be written in a very convenient form in terms of the Euler constant, and that form is known as e to the power I theta. Okay, cos theta plus I sin theta can be written as e to the power I theta. Okay, so suppose I have a complex number r cos theta plus I sin theta, then I can write it as r e to the power I theta. Okay, and this is such a powerful expression that it reduces the um, complexity of the problem to a very simple level, and I'll just illustrate to you how. Let's see. Suppose I have a complex number z1 represented by r1 cos theta 1 plus I sin theta 1, and another complex number z2 represented by r2 cos theta 2 plus I sin theta 2. And suppose I ask you what will be z1 into z2, then what you will do, you'll multiply the two expressions. So r1 cos theta 1 plus I sin theta 1 into r2 cos theta 2 plus I sin theta 2. You multiply r1 r2 are constant, so they come out, and then you normally multiply the expressions. Okay, I with I will give you I square, which is -1. Okay, and so on and so forth. You separate the real and imaginary part and you'll get some expression. You can clearly see it's a lengthy method. It's a very lengthy method because you have to carry out so many multiplications. And just imagine, if I increase this thing, if I write z1 z2 z3 z4, you can clearly see the pain that you will go through in solving this expression. Four expressions you are multiplying together. Okay, very time consuming. Now let us see how exponential form will reduce my time. Let's see. z1 into z2, instead of writing the polar form, which is r cos theta plus I sin theta, I will write it in exponential form. So r1 e I to the power theta 1 into r2 e I theta 2. Now see, r1 r2 is constant. When two numbers are multiplied having the same base, then what happens? The power is added up. So you will get I theta 1 plus I theta 2. Can I take I common? Theta 1 plus theta 2. Now what will be this complex number? Just look at this. Can I write it in polar form? Yeah, of course. r1 r2 and e to the power I theta 1 plus theta 2 can be written as cos theta 1 plus theta 2 plus I sin theta 1 plus theta 2. So this is the final result. This is the final result. You can multiply the expression in polar form and you try to use the various formulas for cos a plus b, and whatever expression you will get, you will finally arrive at this expression. This is just brilliant. This is so powerful. Okay, so you can extend this further. So if I have z1, z2, zn complex number, answer will be r1, r2, r3, rn, and into cos theta 1 plus theta 2 plus theta n plus I times sine theta 1 plus theta 2 plus theta n. This will be the answer. Okay, this is the first thing. We can extend it further to division also. Okay, so suppose I want to write z1 upon z2. So this will be r1 ei theta 1 upon r2 ei theta 2. So r1 upon r2. When the base is same and you're dividing, the powers are subtracted. I theta 1, I theta 2. So r1 upon r2 e to the power I theta 1 minus theta 2. Okay. So when you are multiplying together, the power is added up, and when you are dividing, the power is subtracted. Okay, very basic thing. So these two expressions are used extensively in problem solving. Extensively. So whether it's a question of multiplication or it's a question of division, you can use it, and you can reduce the complexity, and you can make the problem very, very simple. Okay, in the next video lecture I'll continue with this formula, and I'll tell you the rotation of a complex number. What happens when you try to rotate a complex number, how to rotate a complex number. I'll tell you the easiest way using this exponential form of complex number. Okay, so stay tuned and we'll meet in the next video lecture. Thank you.